So far, we have learned how to write exponents, how to deal with negative exponents, and now we're going to learn how to multiply and divide exponents. Okay? So this is the last section before our mid-chapter quiz on Friday. Tomorrow we'll spend some time reviewing. Okay? So what it looks like to multiply exponents. What do we notice between... Let me back up. What we're doing is we're taking two terms and we're turning it into one term. Okay, that's the whole goal today. So what do we notice between 2 to the 4th power and 2 to the 3rd power? They are multiplying. What else? They have exponents and they have the same base. Having the same base is very important because if they have the same base, that means we can keep the base. And then since we're multiplying, we're going to add the exponents together. Okay, so we have 4 and 3. We're going to add those together to get 7. Okay, so if we're multiplying powers of the same base, we're going to keep the base and add the exponents. Okay? You are never, I shouldn't say never. In this chapter, you will not see them without same base. They will always have the same base. Okay, so you won't have to worry about if they're not. Okay? Now, going to dividing. Same goal. We are starting with 2 terms, and our goal is to get to 1 term. Okay, so what do you notice? 3 to the 6th power divided by 3 to the 2nd power. What do you notice?
Same base.
Right, they have the same base, so with that same base, we're going to keep it, and then we are subtracting exponents. So 6 minus 2? 4. So if we're dividing powers of the same base, we are subtracting. Okay, so if we're multiplying, we're adding. If we're dividing, we're subtracting. Okay? Looking here, we're going to work on multiplying first. So when we're multiplying powers of the same base, we do what with the base? Keep the base. What's my base in number 1? Keep the base. What do we do with the exponents? Add them together. 3 plus 5 is 8. Okay, and you don't have to solve today, just writing. Okay? On 2, what do we notice on number 2? Abel.
There's a negative exponent.
There is a negative exponent. We want to worry about the negative exponents last.
Okay, so they have the same base.
They do have the same base, so what do we do with the base? Keep the base. Now, we only have 1 exponent.
You just leave it. What?
On this first one here, do I have an exponent?
No.
Yeah.
Those of you that said yes, what is it? 1, right? If there's not an exponent, we can assume that there is a 1 there. Okay? So if there's not an exponent, we can assume that there's a 1 there. Because anything to the power of 1 is itself. Okay? So we have our base. What do we do with the exponents? We're multiplying, so we add them together. 1 plus a negative 4. Negative 3. Now, what do we notice from yesterday?
When you flip, you have to put 1 over 6 times
Right, because can we keep our answers negative?
No.
No. Okay, so treat this as 6 to the negative 3rd power over 1.
Then flip it.
Yes, now we're going to flip. Now, when we flip, 1 is on top. What's on the bottom?
6 thirds.
6
times 3.
to the 3rd power. Okay? The only thing that happened is the sign of the exponent changed. That's the only thing that happens. And that was our main goal, was to turn it positive. Yeah?
Yes, ma'am.
Remember that from yesterday?
Yeah.
All right. I want you guys to try these on your own. Multiply the exponents. Okay? On number 1, what do we notice between 3 to the 4th power and 3 to the 6th power? What do we notice? Toby, what'd you say?
Same base.
Same base. So what is the base? Start there. 3 is the base. They match, so we keep that base. Okay? Since we're multiplying, what do we do with the exponents? Add them together. So we have 4 plus 6 gives me
10.
10. Thank you. 4 plus 6 gives me 10. Do we have to do anything with that?
No.
No. It's positive, so we don't have to touch it. Okay?
Yeah.
On B, what do we notice?
There's a negative and they're the same base.
There's a negative and they have the same base. What is the base?
7.
7. What do we do with it?
Make it 7.
Keep it. Keep the same base. Now, what is the exponent on the right?
Negative.
1.
It's 1, right? We don't have an exponent there, so we can assume 1. Now, we're multiplying, so what do we do with the exponents? Add them together. -8 plus 1. -7. Can I leave my answer like this?
No.
Why?
Because it's negative.
Yes, because we have that negative exponent. So remember, treat this as over 1. How do we turn it positive?
Flip it.
Flip it. So we have 1 over, what do we have on the bottom? 7 to the positive 7, right? Flip it, it becomes positive. Okay? Now we're going to see, we're going to skip around a little bit. Find this slide for me.
Which slide?
Should be able to just flip your page.
So is it on the back?
Okay, so what do we notice is different from the ones we were just doing to now?
There's exponents.
We have variables, right? Okay, remember what we did with fractions and mixed numbers? How we solved those?
Yeah.
We split them up between whole numbers and fractions.
Yes.
Same thing here. We're going to split them up into like terms. So on number 1, what are like terms?
X.
The x's go together. What else go together?
2 and 8.
The 2 and 8 go together. 2 times 8 go together, our integers. And then our x's go together. Now, those exponents are attached to the x, so they go wherever the x goes. Okay, keep those exponents with the x. Now we just have to simplify. Start on the left. What does 2 times 8 equal? 16. Look at the right set of parentheses. What do you notice there?
Exponent.
They have exponents. What else do you notice there?
They're the same base.
Same base, so what do we do? Or you can, yeah, that's fine. Sorry, same base, right? What do we do when we have the same base?
Keep it.
Keep it, right? So we have x, and then what do we do since we're multiplying? What do we do with the exponents? Add them. So what's 3 plus 4? 7. Can we leave our answer like that?
Yes.
Yes. On number 2, what do we need to do? Abel.
Find like terms.
Find like terms, separate them, okay? What is one set of like terms?
3 and 2 and n and n.
-3 times 2. And then, is it just the ends or what goes with them?
The exponent.
Exponents go with them, okay? Now, what do we do from here? What do we do from here? Abel.
You see that there's 2 bases on the same.
Yep, let's start on the left though. What's -3 times 2?
Oh.
1.
-6. What do we do with the right set of parentheses now? Brecken.
You would bring down the 9s, and then you would
Bring down the n, I think is what you meant.
Yeah, bring down the n, and then add the other 2.
Add the exponents. -9 plus 8.
Is -1.
-1. Now, we cannot do this. But what do we do with that -6?
Keep it.
It
On top.
stays on the top, right? The only thing that moves is what's connected to the exponent.
Yep.
Okay, so that -6 stays, and then what's on the bottom?
And negative, n1.
Oh yeah, 1.
N to the +1 or just n. Remember, once you switch it, the negative
Oh, yeah,
is
it's
gone.
positive n, yeah.
Negative is gone.
Can we keep it like that?
Okay, yes, you can keep it like this. If you keep asking yourself, well, I don't know if I can keep it like that, look for negative exponents. If you have negative exponents, you cannot leave it like that.
Okay.
If you don't have any negative exponents, you're good to go. Okay? Questions over this? I want you to try these next 2. Start by separating out your integers with your variables. On A, what do we do first?
1 second. Let me do this.
Separate first. What goes in my left side?
3 and 4.
3 and 4. What goes in the right side?
Y -2 and y +5.
You got it. Now we just simplify. What's in the left? What's 3 times 4?
12.
12. What do we do with the right set?
Bring down a y.
Yep, keep that same base. What do we do with the exponents?
3.
Right, add them. -2 plus 5 is
3.
3.
No, we're done.
We're done.
Already. That was quick.
All right, on the second part, what can I separate?
-5 and 3.
-5 and 3 go together. And then what else go together?
Or
R -10 and R6.
You got it.
And
Okay,
R6.
now we just simplify. What's -5 times 3?
-5
-15.
times
Negative 15. What about the r's?
Bring it down an R.
Bring one down.
Bring one down. What do we do with the exponents?
Add them because it's time.
So negative 10 plus
Negative
6,
-4.
negative 4. Now, can we leave it like this?
No, ma'am.
15
No.
over
Negative
R.
15
Right.
R4.
Keep that negative 15 on the top, and then bring down that r to the 4th power.
Is that it?
That is it for that one. Yep.
Let's solve it.
One more thing we got to talk about is dividing. Okay, we talked about it at the beginning. Having the same base is still important. So on number 1, what is my base? 8. So we're going to keep the 8. Now, since we're dividing, what do we do with the exponents?
You
Subtract them.
Subtract. What's 5 minus 3?
2.
2. And today you don't have to solve or anything. You can just leave it as 8 squared.
Dang. Can we get
On number 2, what is my base?
2.
2. What do I do with the exponents?
0.
So we just
What do I do with the exponents?
Subtract.
Subtract. So we have negative 2, top minus bottom. Negative 2 minus 2. So keep change flip.
You negative 4.
Would give you negative 4. Can I leave it like that?
No.
No. What does it need to be?
1 over 2 4.
2 to the 4th. You got it. If it helps to write these off to the side, go ahead and do that. Okay. On 4 or 3, what is my base?
D.
D. What do I do with the exponents?
This is constant.
Subtract. Okay, so we have 5 minus a negative 2. Keep change flip. We have 5 plus 2 gives you 7. Okay. Let's look at these last ones. I'm going to do them together to save time. A, what's my base? 4. How do I find my new exponent?
Add them. No, subtract them.
Why are we
Divide them.
Why are we
That's
subtracting?
my fault. I did not mean
Because
to
we're
do
dividing.
We're dividing, so we need to subtract the exponents. It is 6. All right, on B, what is my base?
X.
X. Now, what is my exponent on the bottom?
1.
1. It's not nothing, it's 1. So now we need to subtract 12 minus 1. 11. On C, what's my base? 3. What do we do with the exponents? So we have negative 4 minus 5.
keep change flip.
Yep, keep change flip. What do we get? We get 1. So we have, nope, back up.
3. 3.
Let's start with our numbers again. We have the top minus the bottom. Keep change flip. What do we get? Negative 4 plus negative 5. Negative 9. There you go. So we have negative 9 here. How do we fix that? Abel.
You gotta do their
Yep. 1 over 3 to the 9th power. Last one here. What's my base?
I can't really read it.
Y. What do I do with my exponents?
Subtract.
So we have 4 minus a negative 3. Keep change flip. We have 4 plus 3. Gives you 7. Okay? Write these off to the side if it helps you. Okay? Questions over adding and subtracting. Okay? Remember, if you're adding powers of the same base, what do you do with the exponents? You keep the base. What do you do with the exponents if you're multiplying? You add them. If you're multiplying, you add. What do you do if you're dividing? Subtract.